Welcome to our Tuesday morning math show. Today's episode is called Volumes with Equal Cross Sections, Part 2. Alright, so I have in store for us today I'm going to do an example of equal cross sections involving triangles. So I'm going to take this example, if you would write it down please. I'm going to take the function f of x equals 1 minus x over 2 and the function g of x equals minus 1 plus x over 2 and x equals 0, which is the y-axis. So I want to find the area bounded by those three lines. So quick sketch. This can be thought of as in y equals mx plus b terms as y equals negative 1/2 x plus 1. So that tells me it crosses the y-axis right there. And you fall 1 and run 2. So the first line goes like that. That's f of x. And then g of x is going to be written as y equals 1/2 x minus 1. So it'll cross down here and rise 1, run 1, so it'll come like that. And then we have x equals 0 is right here. So we have, this is the area that we're talking about. So that area is bounded by the three lines that we've just listed. Now I am going to create a solid by having equal cross sections which are equilateral triangles. And the equilateral triangles are going to be perpendicular to the x-axis. And so going back over here, let me draw a couple of these. So if that is the base of one of these, it will rise up out of the page towards you, and it has all three sides equal. So there's one triangle, but it's really rising straight up out of the page towards you. And then like down here, there would be an equilateral triangle like that. And here, there'd be the biggest one. And a whole bunch of them. How many shall we do? Let's say an infinite number, and it's going to create a solid. Very difficult for me to draw correctly. Let me go down here and just kind of sketch that in again. And I'm just going to do one of these equilateral triangles. The fact that this graph actually is bounded by curves in a triangular pattern has nothing to do with the fact that we are filling it with equilateral triangles, because it could be semicircles or rectangles, even trapezoids. So anyway, so here we have one of these equilateral triangles. So I'm going to sum up an infinite number, and they are going to line up across this base from x equals 0 to x equals 2 is where these cross. And so now I just need to know the volume of one of these skinny cross sections. So I know the area of a triangle is 1/2 base times height. So I'll put in the 1/2, and the base is this right here. And I notice it's the distance between the top curve and the bottom curve. So the base is going to be the upper curve, which is the minus 1/2 x plus 1 minus the lower curve, which is the 1/2 x minus 1. And so that's 1/2 base times height times thickness. So thickness is going to be dx. And we'll come back in and work on height in a second. Let's simplify the base because we're going to need that. So integral from 0 to 2, I'll pull out the 1/2. And simplifying this, I get negative 1/2 minus another 1/2. So that's just negative x. And a plus 1 and a minus 1 is a 2. So I'll write it like that. So my base simplified nicely. And now I have to work on that height issue right here. So to do that, I'm going to have to do some side work. Let me pick up a cross section. And here it is, an equilateral triangle. Has 3 sides that are equal. And I'm going to kind of zero in on the height because that's what I need. And if we call this from here to here the base, then from here to here, in this part right here, it's going to be 1/2 of the base. So I am going to pick up out of this equilateral triangle, this right triangle that's coming out. So this is 1/2 base. And the height has come over here, and that's the one I'm interested in. And because the base was, it's an equilateral triangle, then the base was also equal to this side. So I can use the Pythagorean theorem to get this. And this is the hypotenuse. So I go 1/2 base quantity squared plus the height quantity squared equals base, the hypotenuse squared. So that gives me 1/4 base squared plus hypotenuse squared equals base squared. Move the 1/4 over, and we get height squared equals base squared minus 1/4, which is 3/4 base squared. And then I take the square root of both sides, and I get the fact that the height, finish it over here, equals square root of 3 over 2 times the base. And that is a relationship that's true in equilateral triangles. The height is square root of 3 over 2 times the base. So back to the drawing board here. This was the base, so square root of 3 over 2 times the base, in this case 2 minus x is the height. And we're working in dx. So this simplifies very nicely. This can slide across the integral sign, so I get square root of 3 over 4. And this integral is from 0 to 2. And this 2 minus x times 2 minus x is 2 minus x quantity squared. Nah, it didn't simplify quite as nice as I liked, but it's not bad. We can do this as a u substitution, or we can multiply it out. I think just for fun, I'll do a u substitution. U equals 2 minus x. Du equals minus dx. So we have a dx here, but we need that negative sign. So I'll put a minus in here and a minus out here to take care of that. So minus square root of 3 over 4. And this is my u. This is my du. So I can just integrate. This is u squared, so it's going to become 2 minus x to the third over 3. And you're going to get the equivalent answer if you actually square 2 minus x and do it that way. Then you'd have a couple integrals there. to do. And you might prefer that. I am now going to plug in the 2, and I'll get negative square root of 3 over 4 times 2 minus 2, which will zero out. So then I'm going to put the 0 in, and that will be the minus, because it's the bottom limit of integration, which is always subtracted. So we have 2 minus 0 to the third. 2 to the third is 8 over 3. And this is minus times a minus. So I get, simplifying a little bit, I get a positive 2 square roots of 3 over 3. And that is how many volumes, units of volume, so we can say units cubed, that are in my figure here. So write all that down and make sure that you ask me any questions about that one. The triangles are a little tougher than the rectangles, the squares, and even semicircles. So I'll be in a little bit, and I will answer your questions from homework. We'll check over those. And if I'm not there yet, I would like you to start a couple triangle problems. And that's all I'm going to have for you. So the triangle problems are on the handout. And Bailey, there's one for you up in the homework folders in Miss Lisa's office if you don't have the video to look at, or you can look at your book. It's 72B, that one has equilateral triangles, and 72D. That one has isosceles right triangles. So you'll have to mess with this one to figure out the height. It's going to be different than the equilateral triangles. So think that one through. So work on those two until I get in. And I'll also mention that there is been a test, there's been announced a test by Mr. King on Friday. It will cover discs, washers, shells, and these equal volume problems, as well as just hodgepodge of derivatives and integrals, sort of pushing you to get ready for the AP test. So I'll tell you a little more detail about that. So make sure that you put that on your calendar. So test on Friday. And we'll be out of town for a field trip on Thursday. So we'll review tomorrow so that you're good and ready. So I'll be in soon. So I'll stay busy until I get there. See you in a few.